to our video on EIGRP routing protocol. In this video, we'll be covering everything that you need to know about EIGRP. So what is EIGRP? EIGRP stands for Enhanced Interior Gateway Routing Protocol. It's a dynamic routing protocol used for exchanging routing information within an autonomous system. EIGRP is a popular routing protocol used in many enterprise networks. So how does EIGRP work? EIGRP uses a combination of distance vector and link state routing protocol features to determine the best path to each network destination. It uses a metric called composite metric, which takes into account bandwidth, delay, load, reliability, and the MTU size.
If you enjoyed the content of the video, don't forget to like and share the video and subscribe to our channel.
However, a point to note is that in reality, it actually uses only bandwidth and delay as its main metrics. So what are the components of EIGRP? EIGRP has several components that work together to provide reliable and efficient routing. These components include the neighbor discovery table, topology table, routing table, and the diffusing update algorithm, the dual algorithm as it is called. So what are the benefits of EIGRP? EIGRP has several benefits that make it a popular choice among the network administrators. These benefits include fast convergence, scalability, reliability, and support for multiple protocols. We'll learn about configuration and troubleshooting in a later section. In that section, we'll be covering the basics of configuration and troubleshooting of EIGRP. We'll also provide some tips and practices for optimizing EIGRP performance. Remember, EIGRP is a very powerful routing protocol that can help you build a very robust and efficient network. In this part of the EIGRP video, we'll discuss some additional pointers on EIGRP. So join me as I dive into the challenging world of EIGRP and try to explain this complex routing protocol in just 5 minutes. EIGRP, or Enhanced Interior Gateway Routing Protocol, is a key routing protocol used in networking, and for a good reason. Its importance and relevance in the modern network design cannot be overstated. When it comes to routing protocols, there are some common challenges that network administrators face. One of the most significant issues is convergence time. This refers to how long it takes for a network to adapt to changes, such as router going down or a new connection being added. The faster the convergence time, the less downtime the network will experience. And the challenge is scalability. As networks grow and become more complex, routing protocols need to be able to handle increased traffic and number of devices. If a protocol can't scale, it can lead to network congestion and slow performance. Finally, there's the issue of routing loops. These occur when the packet is sent in a circle, never reaching its destination, and can bring an entire network to its knees. These challenges can have a significant impact on network performance. When a network is slow or unreliable, it can lead to frustrated users, lost productivity, or even financial losses. That's why it's essential to choose a routing protocol that can overcome these challenges and ensure efficient, reliable routing. To make matters worse, traditional routing protocols like RIP and OSPF have their own set of limitations. RIP, for example, has a limited hop count, which make it difficult to use in large complex networks. OSPF, on the other hand, can be complex to configure and manage, requiring a high degree of technical expertise. That's where EIGRP comes in, offering a more reliable and flexible solution. EIGRP uses the diffusing update algorithm or the dual algorithm to determine the best path for packets. This algorithm allows EIGRP to quickly adapt to changes in network, making it highly reliable and efficient. Additionally, EIGRP uses a combination of metrics, including bandwidth, delay, load, reliability, to determine the best path. This means that EIGRP can take into account the unique characteristics of a network, ensuring that data packets are routed in the most efficient way possible. One of the key benefits of EIGRP is its ability to provide backup routes in case of a network failure. This means that if a link goes down, EIGRP can quickly reroute traffic through an alternative path, minimizing downtime and ensuring continuous network availability. EIGRP is also highly scalable, making it an ideal choice for large complex networks. And with its low network overhead, EIGRP won't consume valuable network resources, ensuring that data packets are delivered quickly and efficiently. EIGRP's ability to quickly adapt to network changes is perhaps its most engaging aspect. Imagine a network that can automatically read out traffic in real time, responding to changes in the infrastructure or traffic patterns. This is exactly what EIGRP offers, making it an essential tool for network administrators who need to ensure maximum uptime and efficiency. For example, in a network which is very large, a large campus network, let's say, EIGRP can ensure that traffic is routed efficiently even in the event of a link failure or network congestion. In real world scenarios, EIGRP has proven itself to be a reliable and efficient routing protocol. In a hospital network, for example, EIGRP can ensure that critical medical data is delivered quickly and efficiently even in the event of a network failure. In a university network, EIGRP can help ensure that students and staff have continuous access to online resources even during periods of high network usage. In summary, EIGRP is a very powerful routing protocol that offers a range of benefits over traditional protocols. Its fast convergence time, scalability, and reliability make it an ideal choice for network administrators who need to ensure maximum uptime and efficiency. Whether you are designing a new network or optimizing an existing one, EIGRP is definitely worth considering. So thanks for watching, and I'd love to hear from you in the comments below. Have you ever used EIGRP in your network? What were the challenges that you faced, and how did you overcome them? Let me know down in the comments, and don't forget to subscribe for more videos on advanced routing techniques. I'll see you in the next one. Bye bye.